Thank you so much for joining us today. We are excited to present a joint webinar between Noraxon and Kistler. We are going to be discussing the use of force plates for completing jump analysis, as well as the integration of the Kistler force plates into the Noraxon software to couple it with EMG and video to provide that multi-device measurement configuration. So quick housekeeping items for those of you who are joining us for your first webinar today with Noraxon. Thank you. Just as a quick reminder, we are going to have a question and answer section at the end of the presentation today. If you have any questions throughout the presentation, please type them into the Q&A section or you may also type them into the chat. We will be moderating both sections for questions. In addition to that, again, thank you for joining, and I'm going to go ahead and turn it over to Will Lehman from Kistler. He is a sales specialist with Kistler and will be able to take us through the importance of using force plates as well as some of the Kistler portfolio.
Thanks, Zach.
All right, Will, take it away.
All right. So good morning, everybody. So I just want to start off by giving maybe a quick background on Kistler and myself. Let me just move this out of the way. There you go. So Kistler has been around since 1955, and we're headquarters in Switzerland. We have grown to over 2,000 employees worldwide and active in over 50 different countries. We're in a wide range of applications, including biomechanics, automotive, and manufacturing industry. So I'll just give you a background of what Kistler, what we do. We kind of encompass a lot of different applications. And then just some background about myself. I've been with Kistler for just the past 5 years. Before that, I did my master's in sports engineering at Sheffield Hallam University in the UK. After finishing that, I joined Kistler. So, and as Zach said, I'm the biomechanics sales and application specialist for them. So at the end of this, or for this presentation, I hope you guys got a good idea of the advantages and benefits of utilizing a force plate. So start now. So what does a force plate do? So a force plate can give you objective data information about a subject or an athlete performing a specific movement. So for this, we basically breaks down to Newton's laws of motion. Specifically, for every action, there's an equal opposite reaction. So we know force equals mass times acceleration. If we know the mass of a subject or an athlete, we can use the force plate to calculate, we'll get the force. We can then calculate acceleration. And from there, we can then further calculate velocity, center of mass displacement, or jump height, power, break down these the data into different time parameters. And then if you were lucky to have two force plates, you can get asymmetries and see differences between left and right limbs. So just looking at the graph on the right, this kind of just gives you an example of what a counter movement jump would look like. So the small black line here, you have the force, the dotted line, you have velocity, the solid black line, that's power, and then displacement. So these are pretty much all the, not all, but some of the metrics that can be calculated from the force plate. So you can use this objective information coming from the force plate to assess an athlete's strength or weakness. So outside of research, force plates are used for monitoring and training, monitor training programs, evaluating athletes, and also to help determine if someone's ready to go back, either return to the field or if they're finished with a rehab in a clinical setting. So there sometimes sometimes force plates can be underutilized with a focus on just vertical metrics. but the force plates are capable of giving insights to a number of different components in fitness. And these include endurance, stamina, strength, power, speed, agility, and balance. So 7 out of 10 there, it's pretty good. So just to go through those components of fitness and I give you a brief example of how force plate can be used. So to measure, if you want to use a force plate to measure endurance and stamina, you can do a repetitive movement, either repetitive counter movement jump or hop. But you can use these set of data at the beginning of the measurement and compare those to the end. So if, for example, looking at the graph that's up there right now, these are 9 different counter movement jumps, and you can see the first set of 3 compared to the last set of 3 are changed and are different. And that can give you some key insights on an athlete's or subject's endurance and stamina, as well as fatigue. The next one we have here is a isometric pull to measure strength or force exertion. So you can use isometric pull to like a mid-thigh pull. You can do a squat, or even like set it up a isometric bench press to get that max or peak force exertion that a subject or an athlete can provide. So next one is power. So power is a relationship between force times velocity. So a lot of times the force and velocity curve is used to help develop and training programs or prescribe different workouts. So understanding an athlete's power or subject's power can give you a better insight into that force velocity curve. And then also further prescribe what the best training program or repetitions could be. So next one is like speed or time minimization. You're able to break down the force time curve into that stretch shortening cycle, the eccentric to concentric movements, and then breaking those movements down to a time parameter of time of counter movement, time to push off, and then time, or even if you wanted to look at landing, time to stabilize. So having an insight of where your athlete is taking either the most or least amount of time to work through a movement can give you a better insight of what their actual needs are. So this kind of gives you an example. I'll play a video here. We'll just break it down exactly, what that force time curve looks like, and at what point can we break down the time. So you can see here, he started moving this counter movement. So there's that unweighting phase. So from basically 0.5 to about 0.75, he is unweighting, and then he starts to load and push off. And then he has the arm swing, so that kind of will affect the force time curve. That's why it looks a little bit different than the one on the right. But then he has a takeoff. So that kind of gives you an idea of how you can actually slow the movement down and into a graph and break it down and get those different time parameters. All right, so looking at the curve, so we have from A to B, points A to B. You have the unweighting phase from points B to C. You have your stretching phase from points C to D. Then you have your acceleration or propulsion phase of that jump. And then from D on is the flight time. So this is a counter movement jump curve. And from there, you can break down a rate force development and a couple of different things in the curve. And we'll get that into a little bit later as well. So another component is agility. So agility is the ability to change direction rapidly without a significant loss of speed, balance, or body control. You're able to measure, like we just talked about the time parameters, but also center of pressure. So if you wanted your subject or an athlete to do a run or a cut or run and turn, you can break it down to their contact time on the force plate and as well, and compare that to their center of pressure and their stability. So now then going off that, the next component of fitness is balance. or body control. So looking at the, so I'll start with body sway is a good measurement of, a good way to learn about subject's balance. But even looking at the visual of a force time curve can give you pretty good insight of athletes or subject stability or body control. So on the left-hand side here is a squat performed by 4 different subjects. So on the top left, that's what your ideal squat is going to look like. You have your stability phase. So then you have your counter movement and your braking phase, and then your push off. So this is done with 2 force plates. So you have the left and right, and then you have your total force in red. So that top, like I said, the top left is pretty good. Then moving down over to the right, the top right, you can see there's some instability in that braking phase as well as a push off. So you know that there might be some weakness there in the squat. And then now looking to the bottom left, that's still a subject doing a squat, but they're very weak in that braking counter movement phase. Very slow. There's barely it's very unstable, the change in the counter movement or change in force. So that can give you a pretty good insight that they're not very stable going into that squatting position. And then to the right, bottom right, that's you can see that the subject, that they're standing pretty evenly, but once they go into that squat, into that bottom movement or bottom position of their squat, they're all on their left side of their all their body weight's on their left foot or left limb, should I say. And then when they stand back up, they go back to equal. So it might not be something you can see with the naked eye. And then to the right, that's a graph of a body sway, single leg body sway, and you can break it down between medial lateral displacement to anterior posterior, giving you an idea of exactly where that instability lies, either or what plane it lands in. So this kind of brings us to the next part. So one of the largely popular uses of force plates is looking in depth in the stretch shortening cycle. So the stretch shortening cycle refers to the muscle action when an active muscle lengthens and then immediately followed by a muscle shortening. This combination is usually described as eccentric and concentric contractions. So this is most seen when you're going to do like any type of running or jumping. So kind of already looked through the graph on the right-hand side, so I'll go to the next slide. So that kind of brings us also to the next part, which is RSI, Reactive Strength Index. So an athlete's ability to utilize strength shortening cycle is represented by the Reactive Strength Index, or RSI. Using a force plate to break down that stretch shortening cycle can give you a pretty good insight into an athlete's RSI. So you can do things like a drop jump or a counter movement jump, a single leg counter movement jump, a squat jump, or a weighted counter movement jump. You can use these different tests and then break down their data information to calculate RSI. So see on the bottom right, you can do a center of mass displacement. So going back to that first graph, you can use you can calculate center of mass displacement. And then you divide that by ground contact time. So that would be used mostly with a drop jump. The next one, if you're going to do a counter movement jump, you can use center of mass displacement divided by takeoff time, and that'll give you a RSI as well. So the next one is a elasticity utilization ratio. So I think Zach will be going a little bit more in depth into this, but this is it gives an easy example of how you can use your force plate to get some in-depth information on your athlete or subject that you wouldn't normally be able to get. So the eccentric utilization ratio can be calculated using vertical jump height or peak power by dividing counter movement jump by their squat jump. So athletes can generally jump higher during a counter movement jump than a squat jump, due to the storage of elasticity energy and the increase of muscle activity that occurs during the eccentric phase of the counter movement jump. So an athlete's ability to utilize strength shortening cycle efficiently is a critical factor in many sports, like we said, for running and jumping. And then using this elasticity utilization ratio can expose if an athlete's ability or if there's a lack of ability to efficiently use their strength shortening cycle. So it's a pretty quick and easy test, and that gives you pretty good information with whether your subject or athlete needs to work on plyometrics or on strength training. So whichever way you want to choose to use your force plate, the end goal is to help identify your athlete's ability or subject's abilities and needs. Using the data from a force plate, you can help set a target, develop a program plan, then monitor that plan, and then also evaluate their training and their progress. And then from there, you can then either make the adaptations in their training program as needed, or keep them on the same plan going forward. So that kind of brings me to the end of that part of the presentation. I just wanted to also briefly go through the Kistler force plate portfolio, so you guys have an idea of what we can offer. So we basically offer 4 different force plates, and they break down between two fixed force plates ranging in different sizes, and then 2 portable force plates ranging in different measuring range and size as well. And I'll get into that a little bit later. But another thing we offer is a glass force plate. So if you want to put like a high-speed video or a camera underneath the plate and measure center of pressure as well as force, and kind of overlay the two, that's possible with that. And then if you had to do any what you needed a force plate for waterproof, doing any type of gait analysis or any type of training in a pool setting, we wanted to get force data, you could do that with our waterproof force plate. And then last line, I just give you an idea of what we can offer. We have a hand force measuring system, as well as like some specialty items like a instrumented sport equipment box, or a pole vaulting box, sorry. So why you should choose Kistler, and going back to why we only offer pretty much 4 force plates, is because we're allowed to do that because of the piezoelectric technology. So piezoelectric sensors allow our force plates to have a high natural frequency, which is important in dynamic forces and measurements, like for running and jumping. There's an outstanding dynamic impulse response, and there's a very wide measuring range. So instead of having to get a force plate specifically for doing balance analysis or assessments, and then another force plate to do jump assessments, you can use the same force plate to do both. So you can use the same force plate to pick up small shifts in force and movements, as you can to do a jump with large dynamic force generation. So it kind of gives you that wide range of application. So now it kind of brings me to the end or conclusion of part of my presentation. I will now hand it over to Zach to discuss the Kistler force plate integration into their myoRESEARCH platform. Stop sharing.
Great, thank you, Will. Appreciate your run through of the importance and use cases of force plate data. As Will mentioned, now we're going to jump into discussing the integration of Kistler force plates into the Noraxon platform. So give me 1 second here and I will go ahead and share my screen. So as I mentioned, so now we're going to look at the integration of this hardware into the myoRESEARCH software so that we can look at a multi-device setup and start to relate the force plate data to muscle activation patterns, to kinematics, integration of reference video to look at the force vectors, which you can see here on this right side. It's a fairly simple process for integrating these force plates. It's comprised of a few components here, which of course, would first mainly consist of the force plate itself. We've got some cabling that's included as well. An interface box, which actually supports the signal conditioning from the force plate. And then we've got an analog input system to receive those signals and have them be connected and synchronized with the rest of the Noraxon setup. So From there, it's a fairly simple process to get things up and running. Within the software, it's a 4-step process. So you first have to set up the hardware, apply some scaling factors. Rather simple there. There is a sheet that's provided with the Kistler force plates that makes that very easy. And then we've got the configuration set up. So just pulling those force plates in, setting up the channels, making any adjustments to the biofeedback settings or the center of pressure settings that you might have. So adjusting the side, the orientation, the position. And then we also, at that point, you just need to start the measurement. So again, quick 4-step process to get these integrated, and you're able to start to use this data. And what we're going to do then is actually take a look at a live setup so that you all can see kind of how quickly that gets integrated and what that process actually looks like for generating a jump analysis. And then at that point as well, what we're going to take a look at is a comparison of the counter movement jump and a squat jump and demonstrate that calculation of the elastic utilization ratio so that we can start to break down the power and the performance between those two types of jump, and demonstrate the use of that stretch shortening cycle to actually provide a better jump performance, or better jump height rather. So this is a quick example of what that integration might look like. So as I mentioned, we've got a multi-device setup with the force plates, synchronized video, kinematics from the IMU system, and then some EMG signals as well if we want to look at that neuromuscular firing. Well, let me jump over to our software here, and we'll take a look at a live recording. So at this point, I already have everything set up right now, so we're not going to spend any time walking through that. However, at this point, when you do have your equipment already ready to go, all it takes is just choosing your configuration that you have set up and following the green action bar here. And so we'll get activated. I do have 4 channels of EMG, which you can see are the semitendinosus for the right and the left, as well as the vastus lateralis. We went through and we already rectified and smoothed these signals, as well as applied some amplitude normalization so that we can look at the normalized EMG as opposed to the raw signals. However, that is always something that we can take a look at. So if we want to visualize those raw signals, we have those available for us to use, and we can toggle that back and forth should we need to. Adjust my screen layout here real quick. So within this view, what you can see now is we've got a animation here on the right, and that's going to demonstrate our center of pressure for us. So it's going to provide that center of pressure in real time. We've got the integrated video here, which you can see the axes of the force plates are presented to us. And these are going to show us those force vectors so that we can look at where that ground reaction force is actually acting upon the body. And that's going to be important when we want to look at the strategy of the individual who's completing whatever activity, whatever movement that might be. So if I take a step back here, you'll see me on the force plates. And this is all available in real time, so we can utilize this real-time data to perform some biofeedback activities, whether if that's looking at some of those stability measurements that Will was mentioning earlier, if we want to play around with the center of pressure. If we're looking at these squats, for instance, and you want to make some adjustments to the weight distribution, you can utilize those force vectors. But what we're going to do for this example here, as I mentioned, is we're going to do some quick jump analysis. And I'm going to start with the counter movement jump, and we'll go through a recording process so that you can all see what that looks like. So I don't have an operator here with me today, so I'm going to go ahead and just click record and then step on the platforms here. So we're going to go ahead and do a hands on hips counter movement jump. Just to localize it to the lower body here. You'll notice that there's a little bit of a delay in the video, and that's just because we reduced the live frame rate when we click record. So there's a little bit of a delay there, but it'll all synchronize after we make the recording. So to perform the counter movement jump, I'm going to first, stand still, get my bearings here. I'm going to do 3 counter movement jumps with a nice pause in between to give us a real clear delineation between each one of the jumps. So we'll pause. You can always allow your subject to adjust if they need to. And we'll do one more. Pause again. And it's always good to come to a nice rest at the end. We do use that weight calculation from the force plates to calculate some different impulse-driven parameters. The software itself is going to grab that weight calculation from wherever there's the most stable option. But we'll take this here. So we got our 3 jumps. I'm going to call these counter movement jump times 3. At this point, what we can do is actually move right into the squat jump. So I'll go through that process real quick so that we can show how you actually transition from one type of activity to the next without having to waste too much time. So we'll hit save and measure again. That brings us right back into the recording screen here. So now we'll do the squat jump. So it's going to be the same process, except again, with that not having that counter movement, we're going to start in the squatted position. So I'll get down. I'm going to hold this position for a second here. Try to get to about 90 degrees of knee flexion if I can, and then explode. So go down and explode. Okay. Oh, of course, I didn't hit record. One more time. So we'll hit stop there. And there's a, rename that recording, call it squat jump X3. And at this point, since we've done both of our recordings, I can go into the save and view. And here's where we're able to visualize and see that measurement that we took. You'll notice that I've got these signals overlaid on top of one another to give us the difference between the left and the right sides. Move this out of the way. We can always play this back so we can visualize and see what was going on. You'll see here that now we're synchronized with everything. So before you saw there's a little bit of delay when we were doing that live recording. One thing to notice though is with the force curve here, and this was something that Will had brought up here briefly. I'll go ahead and stop it. You see with the squat jump that we start already in that loaded position. So we've got a stable force line here. What you want to try and look for, and the key here with a squat jump is there shouldn't be any unloading. It should just be straight explosion here. So for me, you can see I actually take a little tiny dip. So not the best performance of that squat jump, but that's something to be able to learn and to practice. What we can do at this point now is actually run a report. And so we'll go ahead and follow through with that process. So we click report, choose our jump analysis that we'd like. Hit next, you'll see that the software is going to automatically define where these periods are. So it finds that load, flight, and landing period for us. But we always have the ability to make those adjustments. So if we want to change where any of these are, or the length or the duration, we have that ability to make that manual adjustment. You'll notice that, of course, I did 3 jumps. We could repeat as many as we'd like in a measurement, and the software is going to do its best to pick up all of those jumps. But as Will mentioned, if you're looking to do some sort of endurance test, that's always a possibility as well. So with those defined and looking good, we just have to follow next here, and we've got our jump report. I've got called out just a couple of our parameters here. But you'll see this long list of 22 different parameters. I've just got called out 3 here. We've got jump height, net impulse, and then the reactive strength index on this side. And then on this other side, we've got the rate of force development and then our peak power, which we're going to use to calculate that utilization ratio. In addition to that, we also have our EMG timing. And let me zoom in on this so that we can get a better viewpoint here. So it's interesting to see the EMG timing. We'll take a look at how it differs from the squat jump and the counter movement jump, since we will be utilizing that stretch shortening cycle in the counter movement jump. You see here through the loading phase that we already have that sort of, we're seeing that peak activation already occur. And in particular, when we go into the flight phase, going into that extension, for me, it looks like I've got a little bit more of a dependence on my right side with that semitendinosus firing as I go into the flight phase. But you'll notice that the quads, start to turn off there and then re-engage once we get back into the landing phase here. So we'll take a look at how that differs for the counter movement jump, but I wanted to demonstrate this process for you all real quick. So now if I take a step back, I'm going to go ahead and open up our counter movement jump recording. And so we have that same information. We've got our force curves here. We've got our EMG measurements that we've got going on as well. Of course, we can overlay or change any of these visualization of the data as we see fit. So if we want to see how the EMG relates to the force curves, we can always drag and drop and overlay that information as well. So we can understand, oh, okay, when are these muscles actually firing with reference to the force curve? Of course, that's demonstrated for us in the report as well. But if you want to use any of the graphs and play them back, that's always an option as well in the viewer tab here. Of course, one thing I hadn't brought up yet was looking at that center of pressure. And so this is actually a 3-dimensional object that we can move around and look and see where that center of pressure is. So we have it for the left and the right sides because we have the 2 force plates. And then we have a calculated center of pressure here in the middle between the 2. And you'll notice that there's the orientation here. So we've got body forward and body to the right. And that's important to have set up correctly so that you get the proper center of pressure measurements. In addition to that, you'll see the force vectors, which we were looking at in the live view. But again, when you're playing this information back, you can start to see, as far as what the loading is concerned, where that weight distribution might be. You'll see for me, I've got a little bit more of a shift over to my left side. So of course, I'm looking at the screen right now, and that's probably affecting that a little bit. But then when we actually get into the jump, again, if we want to take one jump here and we want to play it back and we want to see that slow motion representation, we can check this out where, we go into that unloading phase. And then we're transitioning. And then we've got the flight phase. And then, of course, coming up to the landing phase. Let's run this report here, and we'll actually do a comparison of the 2 so that we can get that calculation. So again, the software automatically finds those jumps for us, defines the loading, the flight, and the landing phase. So we just have to proceed. We've got our parameters, the same from the previous report, and then we've got our EMG curves as well. And what you'll notice, of course, is that the loading phase for the counter movement jump is much longer. And in particular, you can see that we see the loading of the quads as well as the hamstrings going through, and that occurs at about, that 20% mark of the total jump period. But that's essentially where we're starting our squat jump from, is right here. So you've got the ability to use that stretch shortening cycle. And ideally what we try to see is actually that we have a higher jump height using the counter movement jump, which has been shown in research. And then we can use those peak power metrics to be able to calculate that elastic utilization ratio. I've edited this report so that we can actually type this in here. But let's do a quick comparison so that we can actually make that adjustment. So we'll hit compare into other records. I'm going to go ahead and insert our squat jump. Got our video images here so that we can look to see if there's any difference between the strategy. And again, let me just zoom in real quick. So for our counter movement jump, you'll see that about 50% of the loading, I do have a pretty heavy reliance on that left side there, whereas, in the squat jump, I'm able to actually keep it pretty symmetrical. As far as the flight phase is concerned, that asymmetry that we're seeing in the loading, you can kind of see how that changes the flight phase as well. So these aspects are all very important, and that's one key thing of being able to include video, is to be able to see what that strategy actually looks like. So now as we go down, we've got we've got all of our metrics, but they're compared to one another. So we've got our squat or our counter movement jump on the left and our squat jump on the right. Very interesting here. So we've got a little bit higher jump height with the counter movement jump, only 2 centimeters, not too much there. But what's interesting is the difference in the peak power. So I actually have less power generation on the counter movement jump than I do on the squat jump, which is a little bit unexpected. But it ends up creating that elastic utilization ratio that's probably going to be under 1. And we'll get back into this, but what that actually means is that I have a poor use of my stretch shortening cycle. And so if I were an athlete and you were working with me, that might be an indication that we need to work on some of those plyometrics. So my strength is good. I'm able to keep that load sustained and explode off and get my body up and off the ground and actually have a pretty comparable jump height to my counter movement jump. But I'm not properly using that stretch shortening cycle to really create the power that I need to even get a higher jump height. So if we were to do that calculation real quick, I'm just going to pull up my calculator here. So we'll do 3973 divided by 4224. So about a 0.94 utilization ratio. And so for this case, I have this set up in the report where you can just double click and type it in. Makes it really simple. And then now let's take a look at the difference in the EMG timing. So again, I think the main thing is, the change in the duration. So of course the pink or the reddish color is going to be our counter movement jump, which you see denoted here. And then the blue is going to be our squat jump. The loading phase, significantly different in the time that it takes, but that makes sense. In addition to that, you'll see how those muscles are actually reacting to that phase, where all we have is just that use of the muscles to explode off the ground, whereas with the counter movement jump, there's a rest period when we start the jump, and then the use of that stretch shortening cycle to actually load the muscles, and then finally, once we get into flight, that's where you see, of course, that hamstring turn on, fully. And then, of course, engage again when we have a little bit of pre-activation coming into landing. I know this graph can be a little bit confusing to look at because everything's phase shifted. But, what we wanted to demonstrate with this particular setup is just how those muscles are engaged. So, of course, with the squat jump, you're seeing them already turned on. So there's really not much more that those muscles are going to provide from an activation standpoint to be able to create that jump. Of Of course, we could start to look at other muscle groups, you know, if we wanted to look at the gastroc or we wanted to look at the soleus and see how those change when we have these two different types of jumps. We could look at any of the other quad or hamstring musculature as well, the glutes. Essentially what EMG is going to provide you in this particular context is if we notice anything, any asymmetries or deviations or leakages, you know, whether that's in the force curve or any of the parameters that we pull up, EMG gives you that ability to start to target where that deficiency is actually coming from. For me, I don't have any particular injuries, so it's not really demonstrating something, you know, super significant. So at this point, we're just looking at the timing of everything. So as I mentioned, we've got our utilization ratio now. We have our comparison here. And what that brings us to is, you know, that feedback loop, right? So we want to, something that Will had brought up, where if we take a look here, and we'll just bring it back up one more time. Get through these slides. So we've got our target setting, we've got our planning of the trainings, and then we did our evaluation, and that was that jump analysis. And so now we can see what's going on, and we can return to the plan to make those adjustments and continue to use this, this scheme here to test and retest and demonstrate objectively if those adaptations or interventions are actually making any difference for us. And Will, I'm not sure if you have anything else to comment on this particular setting, or if you want me to go back to that report and we can take a look at any of those other parameters. But I believe that that's the overall goal here is, you know, we want to use this information from these devices to objectively provide that evidence to either verify our own thoughts of you know, what the training plan might be. Use that evidence to see those changes that are being made. A lot of times, especially for these high level athletes, those are going to be, you know, in the 1-2% difference. And that's something that you're just not able to see with your eyes. Of course, you know, going back into the multi-device setup, again, giving you that ability to really zone in onto a specific portion of that individual's body and see where maybe those deficiencies or leakages are actually stemming from. Because of course the force plate's going to give you that information and tell you, okay, here's where maybe a potential problem is lying. But, you know, breaking it down into the kinematics, looking at the strategy from the video, and then even seeing the interaction or the coordination of those muscles gives you that next level, that next layer to be able to dive into and really start to affect change at the detailed level as opposed from that gross overview. Will, do you have anything to add on that?
Yeah, no, I was just going to say we're looking at a small specific measurement in the elasticity utilization ratio. So you can break that out. If looking at a counter movement jump compared to a squat jump, or even just looking at a counter movement jump, you can break that into many different metrics and results, like looking into the center of pressure of your jump, looking at the force vectors and how they track over, you know, do they track over your knees? Do they come to the inside? Do they come to the outside? And then that can relate now back to stability. Where are you, you know, if there's weakness in your ankles, is there weakness in your knees, your hips? That can all kind of be looked into just from a simple counter movement jump or comparing two jumps to each other.
Yeah, and just to kind of bring that to light here, you know, if we wanted to look at one of these jumps, of course, we've got the muscle activation, we've got the force curves to be able to look at. But then seeing those force vectors, as you mentioned, you know, what is that strategy that's being taken, and seeing that center of pressure as well.
Mm-hmm.
One thing that we didn't necessarily take a look at, but we'll do here real quick, is just the difference between those two force curves. Just to demonstrate here, so we can take a look and see. So we'll pull up both of them, and I'm just going to pull up the FZ signals for these curves here. Let me just change my screen layout real quick. So if we pop out these FZ signals for the two different types of jumps, we have our counter movement jump on the left and our squat jump on the right. Zoom in a little bit so that we can see those force curves there. But again, you're getting that difference here where for the squat jump, we're starting in that loaded position. And so you shouldn't see any sort of additional unloading. And again, that's kind of where for me, you know, my strategy was a little off there. But then it just turns into that concentric phase, and you can see that explosion off the ground and getting that body off the ground. For the counter movement jump, of course, as we demonstrated, you're starting out with your equal body weight and then unloading, and then going into that explosive phase, that eccentric loading phase, and then the concentric loading phase. And of course here, you know, with that stretch shortening cycle, it highlights a lot of those asymmetries, right? If you're, as Will mentioned, if you're lucky enough to have two force plates, you can break down the difference between the two here. So in this particular case, you know, we'll go to that peak force, that first peak that we see, and there's a decent difference between the two, about 100 newtons. And we noticed even when I was standing there that I had a difference on my left and my right side. So clearly a little bit of an asymmetry. And that's even shown here as the unloading, right? I'm able to unload much faster on my left side than I am on my right. And so there's clearly, you know, a bit of a deficiency that I've got on that side. And it's not necessarily brought up by the muscles that we were looking at today, but, you know, again, that's something that you can start to tool with. And if symmetry is important for that athlete's sport, this is something that you can start to adapt and learn and train so that they can have those symmetries and receive them so that they can translate them into their sport and, you know, eventually, you know, not make themselves susceptible to injury.
Yeah.
Anything? Yeah, go ahead, Will.
Yeah, I was gonna say one of the things that you can measure the elasticity utilization ratio using a jump mat,
Yep.
but the difference is that this jump you're taking jump height, which can be unreliable with a jump mat if, you know, if subject jumps and lands with bent knees. But also looking at squat jump, I would say like 7 out of 10 times if you tell a subject or an athlete to do, you know, first time doing a squat jump, they're gonna put a counter movement in before they jump up, and that's just like that's just how their muscle memory is. That's just they're natural to them. So it's a little bit of a learned movement, but it's also something you'd never be able to pick up or know if the subject did do a slight counter movement or even a major counter movement before they're jumping when they're supposed to just doing a squat jump. So that might affect your data as well. So if you're looking, you know, you want strictly counter movement versus squat jump data, you'd be able to tell within the force plate and the data, the feedback, you know, if they did it correctly, or a jump mat, you wouldn't know.